Thank you. Thanks. Thanks for the introduction. Hi, everybody. So today we're going to be talking about USB and JavaScript. So first, if this was going, there we go. Well, Joe already introduced me, but my name is Gergana. And as you heard, it's a difficult name to pronounce, so I usually go by Jerry. If you want to find me on Twitter, and also I am lucky enough to have a weird enough name to have gotten a .dev website without having to pay a premium for it, so you can check out my website. Now, I work for a company called BBD, and I work in the research and development team there. And a lot of the time, people ask me what we do in the research and development team, because not a lot of consulting firms have research and development teams. So the plain, boring answer is that we do training for the BBD developers, we do some specialized consulting, and we also do some research. But that's the boring answer. We also do a lot of fun stuff. We do things like build meme generators. We replace our keyboards with fruit and play games. And me personally, I program astromech droids. That's pretty much how I started out. I hacked a robot and did a talk about it. And now, today, however, we're going to be talking about USB. USB is the de facto standard for wired peripherals. USB, normal USB, micro, mini, USB-C, all of them work in the same way. And connecting to USB devices is usually quite easy because they plug and play. They usually plug them in and it just works. Except every now and then, the dark side of the force. That loading bar just doesn't move. And a lot of the time, you are usually installing some sort of device that you are going to only use once. And those drivers are going to sit on your computer forevermore. But has anyone here had to integrate with USB devices? A couple people, all right. And what languages did you use? C. C, usually, yeah, C++, Java sometimes. You never hear JavaScript, but I'll show you. It's usually not too difficult because the manufacturers of the USB devices provide you with some sort of SDK or API that you connect to, and you link to it, you use the methods. It's not too bad. The problem comes in when you're using an outdated USB device. And this outdated USB device only supports Windows XP with IE8 and code that was written 20 years ago in VB6. Now, Windows XP is an old operating system. It's no longer actively maintained. IE8 is a problematic browser. We've had problems with it forever, and it now has a whole bunch of security issues that are never actually going to be fixed. And then we have the code. This code has been running in production successfully for 20 years. Do you want to be the person to go in and change things and fix it if something's broken? What if you break something else? And let's admit it, developers, we're like magpies. We love new, shiny technology. We never settle for that code that was written in VB6 so many years ago. Let me tell you another example. Now, I grew up on the East Strand. In the East Strand, it's very popular to go out on a Friday evening to get takeaways from some of the popular takeaway places, McDonald's, Burger King, whatever, and even from the Roadhouse. Those places are usually packed with cars. So the cashiers working in those places need to be able to work very fast and very efficient because people are hungry and they want their takeaways. So the way it usually works is you have some sort of desktop application and the cashiers know how to use it, so they work well on it. Let's take the example a little bit further. Say we have our neighborhood roadhouse. Now, This is a touch screen because it works better. Cashier can use it a lot faster. And let's say for the purposes of our example, it's running on Windows. Now, we need the cashier to be able to log in quickly, so we don't want them to have a password that they have to type in. So they have a fingerprint reader, so they can log in quickly. They also have some sort of receipt printer, so they can print out your order. And they have some sort of way of receiving payment, so a credit card machine. These are all connected to the computer somehow, let's say by USB. It's running a Windows desktop application using the SDKs provided by all of those devices, and it's working. The cashiers like it. Everything's fine. But then even our neighborhood roadhouse needs to keep up with the times. So they now want to update to Windows 10. And Windows 10 is great. A lot better than the old Windows, right? But updating requires code changes. And we can update from an old Windows to a new Windows. That's fine. We can write some code. We'll do some changes. The owner is happy. But then a few years down the line, the owner comes in with a bunch of Android tablets and says, we're scrapping these old computers. We're going to use the Android tablets because they're more efficient, or they're cheaper, or they're fast, whatever it is. Now we have a problem. Now we have to rewrite the entire system from scratch because the system that was written for Windows, there's no way of moving it to Android. The reason for this is because the way that USB device manufacturers create devices is they make SDKs and APIs that are native to some sort of platform. So they have different ones for all of the different platforms. So our only option in this case is to rewrite everything. Or is it? We have a new hope. The WebUSB API is a browser platform feature, proposed browser platform feature. It's not on the standardization path yet. That's why I say proposed, because it's relatively new, and they haven't decided that they're going to put it as a permanent browser feature. But it's creating those APIs using JavaScript and running them natively inside the browser without needing to worry about what platform we're using. Now, it works quite heavily with the way the USB protocol works, which means that you have to understand a little bit about how serial actually works. And there are a number of good references I can give you, but they are very large textbooks how serial actually works. So I read some of them, and I'm going to give you the short version. So this is pretty much the code we need in order to connect to a USB device via the browser. You'll notice there that it's very promise-based, so you need to understand JavaScript promises in order to be able to use it. And let's talk about some parts of it. Firstly, the filters over here. We are filtering by a vendor ID. Now, the vendor ID can be found in different ways. Let me show you how you find it on a Mac. Find it in different ways on different platforms, but on a Mac, you have to click on the little Apple icon, click on About This Mac, and if my computer wasn't being so slow, oh, come on, port, and then over here, you can see there's USB, and all of the USB devices that are plugged into your computer are listed over here. If you click on one of them, it gives you the vendor and product ID. The vendor ID is assigned to the device by the manufacturers and the Bluetooth Standards Committee. USB Standards Committee, other one. And together, they assign a vendor ID to that manufacturer, and then they can assign specific products to each of their products. This filter isn't actually required. It's there just to filter out all of the USB devices. So you can put it there so that it only finds specific ones. Then we have the select configuration. Now, a configuration of a USB device, it dictates whether the device is self-powered or not, whether it needs USB to be powered. It also dictates things like how much power it is using, and it also has a whole bunch of interfaces. Once we select the configuration, we can claim an interface. The interface of the device is a feature of the device. You can only claim one specific feature at a time, which means you're taking control of that interface, of that feature, for the time being. And these numbers that you see over here, the number 1 and the number 2, they're usually given to you if you have a data sheet for the device. You can find them in there. If you don't have a data sheet, you can find them in another way, which is a very, very scientific way. So what you do is you say, select configuration 0, and then you run your code. And it says index out of range exception. So then you go select configuration 1, and you run your code until you don't get any errors. Very scientific method. Then we have the transfers. The transfers are how we communicate with the endpoints of the device, how we send data to the device and receive data from it. There are 4 types of transfers. The first is a control transfer. And the control transfer is how we configure the device in order to communicate with it. It usually goes to a default endpoint of 0, and every device has that default endpoint. A control transfer consists of 4 bits. A request type, which is where we are sending control to, what part of the device. So in this case, we are sending it to a specific class. This is set by the USB standards as well as the manufacturers, and they decide where you can send control to. Next, we have the interface, which is the recipient of the control. So we are giving control to the interface. We can be more specific and say that we're giving control to one endpoint, or we can be less specific and give control to the entire device. Then we have a request, and this request is telling the device what we want it to do. In this case, we're sending it a number, and that is saying we need to turn on the following endpoints. Then we have the value. The value is based on the request type. So in our case, we have the class, which is our request type. And the class is expecting a value of 1. And then lastly, we have the index. The index is based on the recipient. So our recipient is the interface. Therefore, you can see that it's 2, the same as the interface we claimed higher up in the code. Another type of transfer is an interrupt transfer. This is for low latency data. So, for example, if you have a USB keyboard, if you plug that into your USB port, every time you push a button on that keyboard, that's an interrupt transfer. We have bulk transfers. Bulk transfers allow for delays and therefore very large amounts of data. So a USB flash drive would use bulk transfers. And the last one is a word I learned recently, so I'm not sure if I'm pronouncing it correctly, isochronous transfers. This is used for streaming audio and video. And generally, with isochronous transfers, you're guaranteed the amount of time it will take to deliver the data, but you're not guaranteed that all of the data will be delivered. OK, so next up, we're going to go into a demo. I'm hoping that the demo does not go like that, but let's see how it goes. For this demo, you can see I have a bunch of stuff over here. The one thing I have is an Arduino Leonardo. The reason we're using this particular Arduino is because not all Arduino boards give the computer full control of USB. So this is one of the ones that does, and therefore you can program it with WebUSB. Now you might be thinking, but I already know how to program my Arduino using the Audrino IDE with C and C++, or even using JavaScript with Johnny 5. But no. So that code, the code that you write in the Audrino IDE and the code that you write in Johnny 5, is still on the Arduino. It still requires some code running on the device. The WebUSB API is for controlling that device externally over USB. So like you would over Bluetooth or Wi-Fi or something like that. So there is still some C++ code running on the Arduino itself. What are we going to do? Well, the first thing we're going to do is blink an LED. Why are we going to blink an LED? Well, because when you learn a new programming language, the first thing you do is write hello world. Hello world of electronics is blinking an LED. So we're going to blink an LED. This is how our LED is connected to our Arduino. And this is my disclaimer that don't try this at home. Don't connect your LEDs directly to your boards. You need to use resistors, because if you don't use resistors, your LEDs could blow. Now, these development boards have some built-in resistance in them. That's why you can sometimes rely on just plugging it directly in when you don't have a breadboard with you, but don't do this at home. And another important part, the LED is plugged into pin number 13. We need to remember that for later. So let's get to it. Okay. So I'll zoom in a little bit. So here we have a simple website. It has some styles in it already. We're not going to talk about the styles because CSS is hard. And we have an index.js and an index.html, which are completely empty. And we're going to start by adding inside some HTML. This HTML has a reference to our style sheet, a reference to our JavaScript file, and two buttons, connect and disconnect, so we can connect to the Arduino. Save that. Okay. Then in our index file, we're first going to get references for those two buttons. So we're going to get a reference to the connect button, button, and we're going to get a reference to the disconnect button. All right. Then we're going to define a device. We're defining it on the global scope because we're going to get a reference to it when we connect to it, and then after that, use it everywhere. So when we click the connect button, we're going to connect. So this code should look very familiar to you. It's the code we were just talking about. The only difference is we have a vendor ID defined over there, which isn't just 0. This is the Arduino vendor ID. And at the bottom here, we're just showing and hiding the disconnect button when we're connected. Then when we disconnect, when we click the disconnect button, we're going to disconnect. When we disconnect, we do a very similar thing, except we're now sending a value of 0 to the class because we're telling it that we're no longer going to be sending instructions, so it no longer requires control. If we save this and go over here. I'm going to use HTTP server to serve that website. Now remember earlier I said there is already some code running on the Arduino. Some of that code is using an Arduino WebUSB library, which allows me to set on the Arduino itself so that it knows what website is going to be connecting to it. So when I take this and plug it into my computer, a little thing pops up over here and says that I've plugged in an Arduino Leonardo and I should go to localhost 8080 in order to talk to it. So I can open that, and we have our website that we made. We can connect. When we click connect, it scans for USB devices, and it finds this Arduino Leonardo, so we can connect. And when you connect, and I know it's really tiny, but you can see at the top over here, there's a little USB symbol right next to the close button. That's kind of a security feature so that you know that if another tab is connected to one of your USB devices, you can identify it. We can disconnect, and it goes away. Now, earlier I told you about my very scientific method of finding configurations and interfaces. There is another more scientific method, and that's by just logging your device over here. Now, if we open up this and just do a refresh, click on the console. When we connect to our device, it logs the USB device over here, and you can see that this device has one configuration, and it's number 1, the one that we were selecting, and it has 3 interfaces, and we're using one of those interfaces. Right, so let's make that LED blink. I'm going to add some more HTML over here. It will just be an input box for the pin number and a button to turn the LED on and off. Save that. Then in here, we need to get references to all of those. So one of them was the connect div, which we're going to show and hide based on whether we're connected. Then we have the, sorry, I lost my spot, on-off button. And we also have the pin number. Then that connected div, we're just going to show it when we're in here. And hide it when we're in here. So USB serial works with unsigned integer arrays. That's what we send over the wire in between the devices. So what we're going to do is define a new unsigned integer array. And it's going to be of size 3, because we're going to be sending 3 different types of data to it. The first type of data we're going to send is going to be when we click that on-off button. When we click that on-off button, we're going to send some data. If we haven't filled in a pin number, I'm going to alert just to warn the user. Otherwise, we're going to send that pin number in the first element of the array, and we're going to send 0 or 255 to turn the LED on or off. So if I haven't messed anything up, I can save this, refresh here, connect to our Arduino, type in pin number 13. Okay, cool. Now I also have a servo motor, which has a lightsaber attached to it because I couldn't think of another way to show you the servo motor moving. And what better way than having a lightsaber? I mean. Anyway, so we're going to add some more HTML. And this will just be a button that will turn the lightsaber on and off. Let's get a reference to our lightsaber over here. I think it was called wave button. And then over here, we're going to, when we click the wave button, we're going to send some more data. So we're using the third element in our data array. That way we can control both things at the same time. Save that. Wrong way. Refresh here. We can connect to the Arduino once again. Make sure that our light still works. Wave our lightsaber. Now, this is fun and cool and a little bit silly, but another example I want to show you is with this device right over here. Now, this device, I got this from one of the teams. I'm just going to stop this because it's distracting me. I got this from one of the teams at work. It's a fingerprint reader. And they were having problems with it because it can only work on Windows 7. So when I first got it, I was having problems with it because I have a Mac. So it was very difficult to get it integrated. And they wanted to move to something newer than Windows 7. I said, well, give me the thing and let me play with it. Let me see what happens. And at first, I didn't realize how complicated fingerprint readers were. But eventually, I figured it out. And I'm not going to show you that code because it's about 160 lines of JavaScript. But it works. And it works very similarly to what we saw here. The code is very similar. It's just a lot more of transferring in and out. So telling the fingerprint reader, turn on this feature. And then you receive back, it's been turned on. Then you say, turn on this feature, and you receive back, it's been turned on. So that's why it's a lot of code. But over here, I have this website deployed to Firebase. So you can see I even used the same style sheet. And if we refresh, I think I'm still connected to the internet. OK. So I'm going to unplug the Arduino, because I don't have enough USB ports, and plug in that. When I hit connect, so here I didn't use a filter, so you can see a lot more devices listed. And it's that one over there. I can connect to it. When I push scan, you can see the fingerprint reader's light turns on. And when I put my finger, it gives me a fingerprint. Now, this is really cool, but I want to show you something even cooler. So my phone, this here is my phone being mirrored. So I'm going to unlock my phone and open up Chrome and go to that same website. Let's zoom in a little. I'm going to plug this into my phone. Hit connect. When I hit connect, it prompts me asking, are you sure you want to connect to this? I say OK, push scan. Fingerprint. So one of the coolest things about this is that it's the exact same code, the exact same website, running on in Chrome on a Mac and on an Android phone. Now, I know a lot of you are probably thinking, but is this safe? And if you're not thinking that, you should be. Because, I mean, websites connecting to your USB devices sounds dodgy, right? And they are doing, I mean, it's a very new API, and they are doing a lot to make sure that it is safe. So some of the things they're doing, firstly, it's HTTPS only. So you know at least that your data is encrypted. We require a user interaction. So we needed to click the button in order to start scanning for devices that are plugged into the computer. So it won't be like you go to a website and it's suddenly scanning your USB devices. It also requires user permission. So when it gave you that list of devices, it asks you, are you sure you want to allow this to connect? And on Android, it's even more explicit. It asks you twice. You can also control it with a feature policy. So feature policy is a mechanism that allows us to selectively enable and disable features like these using an HTTP header, or if it's inside an iframe, then you'd use the allow attribute. So you could disallow WebUSB. There's no human interface device connections. So you're currently not allowed to connect via WebUSB to a keyboard or a mouse or something like that. I did initially think that a fingerprint reader was a human interface device, but apparently this one isn't. So. And then the last one, which is one that someone told me about recently, actually, is that you're only allowed to connect to a USB device once. So if one of your browser tabs is connected to the USB device, then nothing else can connect to it. So there won't be some weird in-between tabs thing. And then support. Now, we saw it working in Chrome, so that's great. Chrome, it's a team at Chrome that's developing the WebUSB API, so that's why it works in Chrome. It also works in Opera, not that anyone uses Opera. Then we have Edge, which is actually a lot closer this way now, because the dev version of Edge is currently in beta, and that's based off Chromium, which means it will work as soon as Edge is based off of Chromium. Firefox is undecided on the issue, because they usually only support things that are on the standardization path, and this hasn't been put on the standardization path yet. And then lastly, our problem child is Safari. So Safari has said no, no way. So for now, there's no WebUSB on iOS. But that's actually all I have for you. Thank you. Any questions?